Sorry for the interruption, you guys. Here's problem number 4. So, looking at this, okay, after all of his gardening work, Jeffrey decides he needs a new shed to replace the old one. His current shed is a rectangular prism that measures 6 feet long by 5 feet wide by 8 feet high. So 6 by 5 by 8. And when you multiply all that together, you get a total volume, which is 30 times 8. 30, 6 times 5 is 30, times 8. 8 times 3 is 24. Add your 0. Okay, so total volume of 240 feet cubed, or cubic feet. It says he realizes he needs a shed with 480 cubic feet. Will he achieve his goal if he doubles each dimension? So 240 doubled times 2 gives you 480. So he's saying, well, you know what? If I just double each dimension, I should have at least 480 cubic feet of storage. Okay, so if he doubles each dimension, these dimensions up here, if he doubles these are the dimensions, okay, it is the same, it is him doubling each dimension. So 2 times 2 times 2. He's doubling them. So we're going to take this answer, 240, and the reason why you see over there it says times 8 is because each dimension is getting doubled. 2 times 2 times 2. 2 times 2 is 4 times 2, which is 8. So now we're going to take 240 and we're going to multiply it by 8 because we just doubled each dimension. So 240 times 8, which gives us 1,920 feet cubed. So, will he achieve his goal? If he doubles each dimension, he's going to get a total of 1,920 feet cubed. Yes, right? He's totally going to meet that goal because he only wanted 480. Another way to solve this, okay, here's another way. 6 times 5 times 8 is actually doubling each dimension, which some of you probably thought of. 6 doubled is 12 times 5 doubled is 10 times 8 doubled is 16. So when you do this, you get 120 times 16, which equals 1,920. You get the same answer. So most of you probably thought to do it this way, which that way is correct as well. So for your explanation, will he achieve his goal if he doubles each dimension? Why or why not? Yes. Okay, Jeffrey's current shed has a volume of 240 cubic feet, which is half of the volume that he needs, which we talked about up here, right? That doubled of 240 doubled is 480. By doubling each dimension of the shed, Jeffrey will get a shed that is 8 times the current size because they doubled each dimension, 2 times 2 times 2. Okay, so to double the volume, to do what he really wanted to do, he really just wanted 480 cubic feet. He wanted to double 240. So to double the volume, he only needs to double one dimension. He does not need to double all 3 dimensions. So if he had a volume like we did, which was 6 times 5 times 8 okay? To double that, all he would need to do is put one right next to it, right? Or stack it on top of each other. So he would need another shed that is this big. Okay, next to it on the side. So the only thing he would do was to double the length here. If he wanted this one doubled, okay, if he wanted it doubled, I'm going to go back, sorry, highlighter. If he wanted this shed here doubled, just put one right next to it, the same one. That's going to give us 480 cubic feet. So all he did was then he took the length, which was 6 feet, and now our length is 12 feet. So now we have 12 times 5 times 8. And this is 60 times 8. 6 times 8 is 48. And then you add the 0. So 480 feet cubed. So all he had to do, you guys, was double one dimension to make it double, not all three. Okay. So you can take a screenshot of what we just did. This is 4B. For 4B, if he wants to keep the height the same, what other dimensions could he use to reach his target volume? So we pretty much just did that. So we want him to keep the height the same, so he could either double the length, which is what we did, right? Or he could double the width. So that's like taking the shed that he built. If you double the width, this was 8 by 6. Okay, instead of by 5, he could double it. And the width here would be 10, this width. So he could take that shed and put another one in the back and make it together and double it. It's a little bit easier to show this on tap blocks. So here it shows you a length of 12, width of 5, height of 8, which is what we did for 4A, or a length of 6, a width of 10, and a height of 8, which is what I just showed you. Okay, and the last one for problem 4 is, after all this gardening work, Jeffrey decides he needs a new shed to replace the old one. His current shed is a rectangular prism that measures... Oh, we already did this. Here we go. If he uses the dimensions in part B, what would be the area of the new shed's floor? Okay, so part B, what we previously did, we had a length... of 6, a width of 10, and a height of 8. Remember that area is length times width. Area. So the area of the new shed's floor would be 6 times 10, which equals 60. So the other one was a length of 12, a width of 5, and the height of 8 still. So length times which would be 12 times 5, and area is 12 times 5, and we know that is also 60, but it's not 60. Okay, it's 60 feet squared. Because area is just length times width. So it's feet 2 times squared. The floor would have an area of 60 square feet, or 60 feet squared. This is the end of our concept development for today, you guys. Remember that the problem sets are an extension, but the exit tickets are what we really want you to focus on and to take a picture and add them to Seesaw. Before we finish for today, I want you to reflect on these questions here that I have to the side, our debrief questions. So what does doubling one dimension, what effect does doubling one dimension have on the volume? So if you only double one dimension, what does that do to the volume? Yes, it doubles it. So if you double one dimension, it's going to double that volume. If you double 2 dimensions, what is it going to do? If you double all the dimensions, what is it going to do? So I want you to think about that. Let's think about that right now, okay? So let's do a quick 2 times 3 times 2, okay? So length times width times height. We have 2 times 2 times 3, which is going to give us a total volume of 2 times 2 is 4, times 3 is 12. Okay, and let's just do centimeters. Centimeters, centimeters. So it's 12 centimeters cubed. So if we double one dimension, if we take our length and we double it, we get 4 times 2 times 3. 4 times 2 is 12. 12 times 3 is 4 times 2 is not 12. 4 times 2 is 8. 8 times 3 is 24 centimeters cubed. So this is one dimension. 1. Okay, if we do 2 dimensions, here's what it looks like. We're going to keep our length doubled, which is 4. Our width we're going to double now, which is 4, and we're going to keep our height of 3. 4 times 4 is 16. And 16 times 3 is 40, what? 16 times 3, you guys, 18, 48. Oh, look. I see a pattern. You didn't even need to do this 16 times 3 over here. Okay? And if we double all the dimensions, we get 4 times 4 times 6. So 24 times 4. 6 times 4 is 24. 16. Carry the 1. 4 times 2 is 8. Plus 1 is 9. 96. And I didn't even need to do my multiplication again because 48 doubled. 48 plus 48 is 96. So now, can you answer that question? Okay, doubling one dimension doubles it. Doubling 2 dimensions doubles that. So you're doubling, you're tripling, and then you're quadrupling all the volume. Okay, next question. What effect would doubling one dimension while having while halving the other to have on volume. So if you, let's say we doubled, so that number 2, we doubled our length, but now we're going to half 2, so we're going to do 1. 4 times 1 is 4, times 3 is 12. So if we double it, double one length, half the other, it keeps it the same size. So that would then be 12. Think of why. And then the last debrief question was, how many prisms can you think of that have a volume of 100 centimeters cubed? A lot. So keep thinking, you guys. Here's another reflection question. So if Jeffrey had been using fractional lengths for dimensions for his planners, how would that have changed the possible answers to these questions? So think about if the lengths weren't whole numbers, if they were fractions. And then your exit ticket is here to follow. A storage shed is a rectangular prism. A storage shed is a rectangular prism and has dimensions of 6 meters by 5 meters by 12 meters. If Jean were to double these dimensions, she believes she would only double the volume. Is she correct? We just talked about it. So I'm excited to see your answers for this exit ticket. See you later, everyone.